Hello everyone. In this video we shall learn what spherical mirrors are. So what are they? So as you can see there I have put up a sphere over here, a three-dimensional representation. Now to define spherical mirrors we first need to see this, and then let's do one thing. With one plane, let's cut out this portion. Suppose, okay, this is a plane, okay, this is a plane that cuts out this portion. Okay, now I want to give you a more proper visual representation. Okay, now this is simpler. Okay, as you can see, this is the plane, but then it is it seems like a line because it is a two-dimensional view. Now it is a plane actually. So we have cut out this portion, alright, from the sphere. Now this cutout portion will look like, or probably look like, something like this. So it is curved now. So now when you see this from this angle, so it will look something like this one. Okay, now in this let's assume that the reflecting surface is curved outwards, alright, and when it is viewed from this angle we see this. But suppose the reflecting surface in the curve is curved inwards, alright, this direction, then it might probably look like something like this. It's not a proper, it is not very shiny inside, okay, but this area, or rather this area, is the reflecting surface. Now it is curved inwards, alright, in this case. Okay, so we say that now these two mirrors, either having the reflecting surface curved outwards, or this one, the reflecting surface having curved inwards. Okay, these two mirrors are known as spherical mirrors, alright. Okay, now let's come back to these diagrams, three-dimensional diagrams again. Okay, so let's define spherical mirror. Spherical mirror is a mirror whose shape is a piece of a cutout of a sphere whose reflecting surface is either curved inwards or outwards. Now this is curved outwards, the reflecting surface, and the reflecting surface in this case is curved inwards. So generally we call this one as convex mirror, and this one as concave mirror. Okay, now let's understand some few important points regarding the spherical mirrors. So as we have discussed, here is the cutout portion, that is the mirror. Let's say, for instance, let's not decide which side is the reflecting, the outward or the inward, we don't know yet. Let's just say it is the cutout portion. Okay, now it is a cutout portion of this sphere. This sphere will be having a center, right? Okay, this center, with reference to this cutout portion, it is called as center of curvature, and the point over here, which is the farthest from the center, okay, let's say this one, is called as pole of the spherical mirror. And now the halfway between the midpoint is known as the principal focus, and the line joining these two, the pole and the center of curvature, this line, okay, this line is called as the principal axis. Okay, for both the spherical mirrors, both concave and convex mirrors, these terms exist and these points exist. Okay, now I want to show you in a three-dimensional representation again of these points. Okay, convex mirror, this is the pole, this is the principal focus, this is the pole, and this is the center of curvature. And the distance between pole and the center of curvature is known as radius of curvature. Alright, I'll show you for the concave mirror as well. There you go, we have the same thing, the center of curvature, the principal focus, the pole, and radius of curvature, this one, this length, and this is the principal axis. Even for this is the principal axis. Now so far I've shown you so far are the three-dimensional views. Now in actual learning mathematical calculations, we usually follow the schematic 2D diagrams. Now let's come to that. Okay, now this is the schematic two-dimensional diagram of the concave mirror. Okay, as you can see, this is the center of curvature, this is the principal focus, this is the pole, and this is the principal axis. Now let's say a parallel ray comes in this direction and it is incident on the surface. Now it has to pass through the, when it bounces back, it has to pass through the principal focus. Now it goes like this. Okay, we will not go into detail about this in this video, but in the coming classes, coming tutorial videos, we shall learn that. Similarly, we have here convex mirror. It is shown this way. Alright, a two-dimensional schematic diagram. The side which is not shaded is the reflecting surface, as I've mentioned earlier. So in this case, suppose we also have what, as I said earlier, we have a pole here. Alright, then let's say we have the center of curvature somewhere here, and the midway we will have principal focus. Principal focus. Now suppose a ray of light comes parallel to the principal axis. Let's say, like, okay, this color is not so good. Okay, let's say a parallel ray, okay, parallel to the principal axis, a parallel ray comes towards the convex mirror. It's not straight, and it is incident at this point, suppose. Then it reflects back, it bounces back as though it is coming from the focus, the principal focus in this case. Okay, these are the two spherical mirrors that we have to understand, and this is it. Okay, before we finish off this video, I would like to introduce one more term, that is aperture. Now, aperture is basically the size of the mirror. So you say that it is the diameter, alright? Diameter of the, this thing, mirror, or rather the spherical mirror, right? Spherical mirror. Now suppose if you view from this side, as we have also seen earlier, I want to show you again, the aperture can be seen as like this. Okay, so the pole would be somewhere here. Now this example is for the convex mirror. Now same thing goes for the concave mirror as well. Now, okay, thank you. We shall learn more about it in the next coming videos. Thank you.